Good morning, everyone. Welcome to our webinar on sketching in an iterative environment. Today we're going to take you through some of the tips we have acquired over the years using Autodesk Inventor and how to produce robust and predictable sketches. Let's face it, the world is changing and we are no longer isolated to doing everything ourselves. Within the design department, nearly everyone has to work on multiple projects, collaboration with users both inside and outside of our departments and companies. With that, we also need to create sustainable designs where reuse increases profitability. With that, we need to be able to ensure our designs are efficient, easily editable, and requires little outside intervention when others need to use our design or edit our design. We're going to concentrate on design intent in this webinar and ensure that when others need our design, they can easily understand it and edit it. So, what is sketching in an iterative environment? Well, the first thing you do when you start a new design is you need to try and understand what your design intent is. You want to focus on more of the shape and its relationships to other pieces of geometry than just the size or the dimensions. Having an understanding of each of the features and how they will relate to each other long term will give you an advantage when it comes time to edit a design. The first thing to do when you begin your design is to try to understand what relationships are needed: horizontal, vertical, parallel, concentric, etc. At the lowest level, you can look at those horizontal and vertical relationships and set those in respect to your UCS, so how your sketch set is stuff up. From there, I generally like to expand that into both parallel and concentric and symmetrical relationships. Because remember, how these relate to each other could assist you or bite you as your design becomes more mature. The first thing to do when you begin your design is to try to understand what relationships are needed, an order of magnitude, if you will. Begin by looking at the lowest level of entities and drawing them using the inferred constraints. Inferred constraints being the ones that are automatically placed. And then you can start to expand and add additional constraints. Will this line be parallel to that? Will this circle be concentric? Are we going to have to add some symmetry to that? And then you can go ahead and add dimensions as needed. Now, the reason to add constraints is they add stability to a sketch. By first adding constraints, you establish the overall shape or intent and the behaviors long before the size of the components. After doing your constraints and you're comfortable with that, you can go ahead and add your dimensions. You generally add smaller dimensional values first and build up to the large ones. Doing this keeps a part from flipping inside out or becoming totally distorted. If you don't want to have to back up, this is a great direction to go. Also, if you see the need to, feel free to relate one dimension to another. So if we know that a part is going to be half the size or the whole is going to be offset from the edge, feel free to utilize one dimension to generate the other dimension. And remember, if you do follow these steps, you will get a very predictable sketch. So, before we get any further, we all know about the KISS theory. We want to keep it simple, stupid, right? Don't try to design everything in one sketch. Use smaller sketches, simple sketches. It leads to unnecessary complication. This is true especially during editing. Keep them simple, limited amount of entities. They're also easier to constrain. Another part is try to avoid fillets and chamfers. They're best left for features. Right? In some cases, yes, it does make sense, but overall, in the end, it makes sense to add them later. They're easier to edit. They don't affect other sketches. So why are they there then? You could ask. Well, in some cases, it's actually better to use them. For example, if you have a plate, if you're using plate blanks from a manufacturer that uses rounded edges, they will always have rounded edges. So go ahead, add that into your sketch because your general component is going to be rounded edges. It's not going to change. It comes from a manufacturer. That's where we start. So just go ahead and do those. Another simple way of making sure that your sketches are predictable is to constrain to the origin. Right? Every component has an x, y, and z of 0 or 0, 0, 0. If we constrain to that or use that to dimension to on a regular basis, then our sketches will also become predictable. If you always want to have that origin point pushed into your sketch, all you need to do is have it projected anytime you create a sketch, and you can do that by going into Tools, Application Options, and under Sketch tab, check the box for Auto Project Part Origin to the sketch. With that, let's go ahead and take a look at how Inventor sketching works at the lowest root level. So let's go ahead here and start by first setting the application options. We'll set the auto project point to which is the 0, 0, 0 to show up in a sketch, and we'll also set the look at sketch to make it normal to the screen. I'll now jump back to my 3D model and start a 2D sketch. We'll start this on the XY plane and then come out. Now here's that 0, 0 point, right? It's automatically projected. I'm thinking about a rectangle, but I'll go to the line and we'll draw a line and we'll drag it out a little bit. And here you can see the horizontal glyph, right? It's just kind of showing off there. That's the inferred constraint, if you will. We'll pick a point and then we'll drag it up. And what you're going to see here is it goes to perpendicular. Again, setting priorities, perpendicular and parallel are over the horizontal and vertical. Again, we'll pick that point. We'll drag across. Now you'll see that this line is becoming perpendicular to the horizontal line. I'll brush across the lower line, and that'll now make it parallel to the lower line. And then again, now I'll reference the endpoint, bring it up, make it parallel, click, and then turn around and close it off. So we'll see we just quickly created that nice little rectangle, if you will. We'll go up here, take a look at it. You can kind of see that if we drag it, it's got all its constraints tied together with it. And now we'll go up and we'll make sure that the midpoint and the center point, so the midpoint of this vertical line is horizontal to the center point. I'll do the same thing, making sure that the 0, 0 and the midpoint of the horizontal line are vertical to each other. Finally, we'll add some dimensions. We'll make this 6 inches. You'll see that as we scroll out. Now we'll place this horizontal dimension. Actually, you can see that this is already constrained in one area. We'll place this dimension now. That will be 10 3/8 of an inch or 375. And we have a fully constrained sketch. All right, so let's finish this sketch out. Zoom out to now create our extrusion, and we'll extrude this out, and we'll extrude it at a 0.625. Now that we've finished creating this extrusion, let's go ahead and add a new sketch onto the side of the part. And we'll place this here, kind of adjust it a little bit. There you go. And then we'll draw a rectangle. First, we'll put one up at the top here like this. And then we'll put one down here at the bottom, kind of like that. Just kind of sketch them in quick. Then we'll turn around and we'll add an angled line on the top one, and then again at the bottom one. So now, as you can see, we just have two rectangles, totally unconstrained outside of any inferred constraints. What we're going to do next is add a line, construction line, to tie the two endpoints together of the angled lines. What this will do is we'll actually add a constraint that says when one moves, the other one will move as well. And we can see that just with the drag. Let's add a vertical constraint here. We'll see that the two endpoints are now on top of each other. And as I drag, you can see that they go with each other. Let's turn around now, add a collinear constraint to the edges of the part and to the sketch, kind of join them back to that base feature, if you will. You'll see that the two endpoint lines are already collinear. And now if we kind of drag it, you'll see that they stay, with that edge. You'll see the parts, the lines all stay, vertical to each other. Let's go ahead and add another construction line now. And we'll put that from the origin point out to the edge. And we're going to use that to create a symmetry around this line. So we're going to take the angled lines, select those, and then select the construction line. And we'll now see that the angles, as they adjust on either side, will always remain symmetrical to each other. And dragging it from here and there, you'll see that, again, we've added some design intent to this component. Just drag it around to see what happens. Let's go ahead and add some dimensions. We'll add a 45 to here. Boom. So they're both at 45. Let's go ahead and finish up adding some dimensions to this component. 225. And let's go ahead here to there. We're going to make that one 250. Continue. You see how it's changing. With changing colors, it's becoming more and more constrained. Add an endpoint 150. Let's add a dimension between the two portions of the sketches. We're going to put it here and show off the symmetry. We'll make it 3 inches. Just to kind of show it. You can see here it's fully constrained. Let's go ahead and edit the 1.5 to 1.25 and then back to 2. So now we can see how it moves around. It adjusts evenly. We'll finish it up, create an extrusion, choose that one, and cut it all the way through. And there we go. We have our component. Now that we've seen a few pointers on creating a good initial sketch, let's take a look at how to interrogate a sketch someone else or you has previously created. We're going to take a look at how it was constrained, if anything is unconstrained, how to predict what will happen to a sketch should dimensions be edited or added in the case of an under-constrained sketch. To do this, we're going to take a look at what makes up an intelligent sketch, including degrees of freedom, constraint glyphs, and dragging of geometry. One of the pieces of information we can obtain is how much unconstrained movement is available in a sketch. This is referred to as degrees of freedom. In a 3D modeling environment, there are 6 degrees of freedom, 3 rotational and 3 translational. But since we're working in a 2D environment, we can actually automatically assume 3 of those are consumed by the sketch plane that the entities are drawn on. This then now leaves us the other 3 to be concerned with to create a robust sketch. To display or hide the glyphs representing the degrees of freedom, you can just right-click in the background of a sketch and select Show All Degrees of Freedom. This will display glyphs associated with all under-constrained entities. All fully constrained entities will have no degree of freedom glyphs. If you do have any available degrees of freedom glyphs shown, as you continue to place constraints and dimensions, these glyphs will disappear or be consumed. The constraint glyph is another tool that we can use to understand how a sketch is constrained. These are small icons located next to the entity in which a constraint is placed. You can display these glyphs individually using the Show Constraints command located on the Constraint panel of the sketching toolbar. If you want to display all the constraints at once, which is an option, you can right mouse button in the background of a sketch environment and select Show All Constraints. Or, to make it a lot more simpler, you could also use the F8 button and it will also display all of them. Now, to get rid of those, this is probably going to fill the screen up depending on the complexity of your sketch. You can actually hide them by right mouse button over a shown glyph and then select Hide. There are also several other options we'll get to in a second. If you want to hide all of them, you could easily do so by right-clicking in the sketching background again and now select Hide All Constraints, or alternatively use the F9 key. Hovering over a constraint while they are on display, or a constraint glyph while they're on display, will highlight the two entities that form that relationship. So you'll see two lines, or a circle and a line, or a point highlighted. This is used for the purpose of understanding what the designer's intent was, aka the design intent. Did he mean the entities to be parallel? Did he mean them to be perpendicular or symmetrical? And so on and so on. To remove a geometric constraint from a sketch, hover over that constraint glyph, right mouse button, and select Delete. This will remove the constraint from the two entities it has been applied to and return some degrees of freedom. A simple approach to see if an entity is fully constrained can be accomplished by trying to drag the geometry in the sketch environment. This is considered one of the most effective ways to understand the effects of a dimensional change or a constraint edit or addition. Select or left mouse button an entity within the sketching environment and then hold down that button. Drag the mouse around to see if the entity will move or the effects of moving that entity. If you'd like to get an insight on what direction it may move, be sure to turn on the degrees of freedom glyphs so that you get a preview of the possible directions it can be moved in. Because remember, the entity will only move in the directions it is allowed to based on what geometric constraints are applied or what dimensional constraints have been added. Now, let's go ahead and take a look at the interrogation of some of these sketches. All right, so let's go ahead and take a look at the sketch here. You'll notice that the upper side of it here is constrained, fully constrained. We can tell by the two colors as well as there's no extra looks at it. This one is an under constrained portion of the sketch. We can first start by right-clicking and saying Show All Degrees of Freedom. This will now display all the glyphs and the direction that the entities can move in. So you'll see that I can drag these in certain directions. They've got some rotational to them as well. So we're looking at, three possible degrees of freedom. As we add constraints, these will disappear. The other thing we can do is we can see which constraints are already applied, and we can do that by right-clicking and saying Show All Constraints, or possibly using the F8 key. So if we do that, now the constraints from the constraint portion show up. So we can look at, a fixed constraint. Or if we look at this collinear, it shows in one side as well as the other. So it shows pairings of those. To get rid of those, we can actually right-click again in the background, say Hide All Constraints, or use the F9 key. And then all the constraints will no longer be shown. Another option is, if we're trying to review the model, is to turn on the constraints, highlight one, right-click, and do a hide. That will take those away one at a time, or pairs at a time actually. So those two will now disappear. So again, I can clean my screen up to do this. So let's go ahead on the bottom here and take, kind of add some constraints to this. So we'll add a collinear constraint like this, and we'll do another one here. So that constrains it. We'll see down the bottom the 7 dimensions are needed, so we're gaining on it. Let's put some parallelism in. So we'll make this parallel to that, and then we'll make this parallel, and actually we'll make it perpendicular to this one. There we go. All right, so now let's turn around and add some more constraints in the form of dimensions. So we'll put it here, we'll go here, we'll place this at a 45 degree, making it reference the other one. And then we'll add a dimension from the endpoint here to this edge. Bang. And then we'll do an overall dimension of here to here, and we'll make that 3.5, and that looks pretty good. Let's actually change this one. We'll make it 1.375, bring it all down. And then the final dimension here, we'll make that 2.25. There we go. Boom. Now we have our sketch fully constrained. So you could see as we went on, the degrees of freedom disappeared. We've got some extra constraints now. If we show them, these all show up. We go ahead here, hide the constraints, hide all the degrees of freedom, finish our sketch, extrude it, that section, cut it, all, bang. We now have our component cutouts done. So what happens now is you've been, interrogating sketches, you've seen them all, now you've got to go and make a change, and you find that you're making a change to someone who actually created a great sketch, did a fantastic job, and constrained everything. But now you got to move stuff around, right? No degrees of freedom. So while you're editing a sketch, you discover it's fully constrained, and now you need to override those. Well, you can use the relaxed constraint settings, because many times it's more beneficial just to let the program override some of those than it is for you to go through one at a time deleting constraints. When you use the relaxed constraints commands, it affects both the dimensions and geometric constraints. But you have the ability to be somewhat selective with those constraints on which ones get relaxed. To accomplish this, go into the constraint setting dialog box on the inside the sketching toolbar and switch over to the relax mode tab. This is where you would enable it by selecting the checkbox. The tab then allows you to choose which geometric constraints you'd like to override or have flexible. Select the ones you desire, are there any combination of, and hit OK. Now, for dimensions, any dimension, there's a checkbox there that says that any dimension that has an equation in it will be retained. So if you don't have it in there, an equation in there, it will automatically be overridden, but you can still have a little bit of control on that. So now, one final thing on the relaxed. Be careful when you're using this, because once you turn it on in the sketching environment, it will stay turned on until you leave that sketching environment. So word to the wise, turn it on, do what you need, go back in and turn it off. And then from there, you can continue your designing as needed. So let's take a look. So let's take a look at this part that we just recently created. And if you remember right, we can see that this is basically the sketch that we worked on. It is fully constrained. We can see that. So if we try to, take a look at the show all degrees of freedom, nothing shows up. Plenty of constraints. We try to use the drag that we talked about. It doesn't move. But we need to, assuming make these a little more even. So we've got to adjust it. We have two choices here. We can take the dimensions off, adjust them, or we can actually use the tool called the relax mode. And what the relax mode is, which is accessed here under the constraint settings, it allows us to take those hard constraints, things that parametric modeling have always, forced rules into, and turn on or off certain ones that we want to relax. So in this particular case, the horizontal, verticals, parallel and perpendiculars, etc., are all going to be relaxed. So anything I have checked will be relaxed. It also says preserve dimensions with equations. So if you remember right, we actually took the dimension here, this 45, and actually made it reference to that. That one will be locked. It will not be overridden at all or relaxed. So we'll go say here, OK, And now watch, it's still fully constrained, but watch. I can now drag it, and it immediately comes back to being fully constrained. I can change the sizes, kind of give me a conceptual, if you will. See what's going on. All right. We can also now take this and then add constraints back. So I'll be able to go back here, and I'll get a warning when I do that. You know, it says it's over constrained. Well, it makes sense. It's a fully constrained sketch. But since I have the relax mode on, it'll allow me to change it temporarily to driven and then continue. So here and here. And we'll put this one back on top of here. Again, anyone that has been changed over. Boom, boom. And now that we have this all taken care of, we can actually just finish the sketch, see it update, and you can absolutely see that it's now much more symmetrical than it was. I think something that everybody has seen at least once, if not many, many times within their modeling careers is that missing reference dialog box. Missing reference or projected geometry will pop up. The funny thing is, though, I find that a lot of people don't really fully understand why they're getting it, but we can talk, we'll talk about that real quick here. Generally, it is caused when you dimension or create a geometric reference, such as, concentric, to a sketch entity from a consumed feature, and that is no longer available. You've either deleted it, replaced it, or done something like that. So, for example, if you had a hole in your plate or in your component, and you then created a new sketch and dimensioned from that hole to another hole, well, if you went back and you deleted the hole and replaced it or just got rid of it because you don't need it anymore, it's now not going to be able to be referenced. It's not there. So the downstream part that had a dimension to it is going to say, hey, it's missing. We need to do something with that. To keep from having that happen in general, what I like to suggest for people to do is to dimension either one to the origin, that as much as possible. When we projected the origin point, it gets projected on every sketch. If we can do that, then that never moves. The other thing is try to use some of the base feature edges or geometry, things that aren't going to change, edges of the parts. If you have a standard cutout that you started with, if you go back to the base feature and always reference off the base feature, you generally don't get the missing projected geometry. But if you do happen to get that error, don't fret. It's not too hard to overcome. It's basically you need to go back into the sketch and one at a time resolve the errors. They'll show up as purple or magenta depending on your color scheme, and you basically remove that reference geometry, delete it, and then just redimension it. It's not too hard. It's just a lot of times it happens and it's really overwhelming. There's a lot of parts, especially at the assembly level. But if you just break it down one at a time, you'll have no problem just rebuilding it, and then you can go back and rebuild it back to the way it should be. Alright, so let's take a second now. We're going to take a look at this completed part here, and we're going to make a change to it that actually, breaks it, if you will. We'll remove some of that geometry that causes the error, just so you can kind of see what's going on. So we're going to start by taking this plate away, this raised boss, if you will. I'm going to do that really simply by going here and editing the feature. We'll grab the profile, and we'll just deselect it from the profile loop. And I'll say OK. And I immediately get the dialog box here that has some errors to it. So 7 loses a coincidental constraint to reference geometry, and 5 loses a couple of dimensional constraints. Not an issue. I see this all the time. We help people with it all the time. Basically, we're just going to accept it. We'll go over to the browser. We'll see where the issue is. If we remember right, we have the sketch. It's got a little eye symbol for information. I can turn around here now. Got a couple of options. I can just go directly into edit to sketch, or I can use the recover command, which will give me a little bit more information. This is the sketch doctor, if you will. It'll tell me that it's got undimensioned dimensions unresolved. So as I select it, you'll see that they highlight. So, in a complicated sketch, this is probably helpful to narrow it down and kind of isolate where your issues are. I'll hit the next. It'll tell me what's going on. It'll give me a possible solution. In this particular case, it reiterates the dimension to reference geometry could not be resolved. Go ahead and use the edit sketch. So as you do this more often, you kind of get used to it. And then on the finish button, it'll go right into the sketch. Let's go ahead and take a look at the edge. Here we go. And really, just the only fix that I know of is you just keep hitting the delete key, and it's gone. And then now we don't have a fully dimensioned sketch so what we'll do is we'll go off the back edge to the front here. We'll place that, accept the value. We haven't moved anything, so we know the value is going to be good. And then we'll go from this point to that edge, and we'll make it here. And that puts us back into a fully constrained sketch. You'll still see that the eye or the information is available there. I'll do the finish. That one now disappears. We still have one left for extrusion 5 and sketch 7. We're going to have that same deal. So let's go ahead here now. We'll just jump directly into this. We know what the issue is. So we'll jump directly into edit the sketch. You'll see the same thing. We have a piece of reference geometry. In this particular case, it's off the midpoint of that pad, and that pad is now gone. So we're actually going to have to add a dimension back. So we'll see that, we lose some of the constraints now. We'll throw a dimension, from that point to that point. We'll accept it, and it'll now come back. So we still need one more dimension someplace. So it looks like it's got that little point that's left over that we don't really need. It's setting that it's vertical. There we go. So we'll get rid of it. Now we have a fully constrained sketch, and we can go back to our geometry. So life is good, right? It's not hard to do. It's just takes a little bit, breaking it down one step at a time. And again, remember, try to resolve from the top to the bottom, making sure that your parent is good before your child. So let's conclude here. First off, using sketches smartly in your design. It's not something you should take lightly. I mean, really, it is the cornerstone to your design changes later. Having good, solid sketches always creates highly robust models. So whenever you can, planning out where you place your constraints and what features, are you just using to constrain from really makes a difference, especially during editing. Always start with, after creating your geometry, adding geometric constraints, as this defines your design intent or how the model will behave as different sizes are applied to it. Follow that up by placing dimensions on the sketch to define its overall size. But remember, when you're creating those dimensions, please try to dimension from either a base feature or use some of the origin work points or axes, the 0, 0, 0, if you will. Also, aim for a completely fully constrained sketch every time. Use your degrees of freedom to see what you've got left. Take the visual clues. Use the lower left-hand corner to see how many are left. Always all good visual tools to let you know if you're going in the right direction that you want. And if for some odd reason your features do become an issue, just take it one step at a time. Step back, start at the top of the tree, and work your way down the browser, fixing each one in that order. There's a reason it calculates in that order. So if A, B, and C is broken because of B, if you fix C before you fix B, it may not work correctly again, and you're just creating a spaghetti pile that way. So fix B, then fix C, and move on. And you'll be surprised because sometimes actually if you fix B, C sometimes also gets fixed. So again, work through it. If you'd like more information or anything else, feel free to reach out to us at www.m2t.com. There's a bunch of information out there, events going on, blogs, promotions, you name it. You can get contact information for most of the people that are there, including technical support, as well as your sales rep. Also, as a closing piece, I'd like to tell you about some of the other webinars that we have coming up over the course of the next couple of months. So as you can see here, we've got some EdgeCam, some Inventor, some CAD stuff. Please go to our website, look it up, register for these, enjoy us, tell us how you like them, tell us what you want, and we're just here to make your life better. And again, thanks for attending today. I hope everybody has a great weekend.